Hello, guys. This is Engineer Zushan Akbar with a problem. As I committed in the last lecture, that I will solve a problem relevant to gradually varied flow to assess the type of the main type of profile and the subcategory of the profile. Either the profile is mild, steep, critical, horizontal, or adverse, and the further classification of the profile. For this, I have included this problem. Here you can see that we have a statement of a problem in which we have a rectangular channel. The channel is of rectangular shape. So simply we will draw a rectangular channel here. A rectangular channel with a bottom width of 4 meters. The bottom width of the channel means B is equal to 4 meters and a bottom slope of 0.0008. S naught or bottom slope of the channel is 0.0008, has a discharge of 1.5 cumex. Let us say the depth of flow is this one and the amount of discharge in this channel is 1.50 meter cube per second or cumex. In a gradually varied flow in this channel, if the flow is GVF, means the type of flow is GVF, the depth at a certain location is found to be zero point 0.3 meter. This depth is not at this condition of 1.5 meter cube, but this depth is found at any other point or any other section at which we were observing. So we call this as the depth of non-uniform flow. That means, as we discussed in the last lecture, that gradually varied flow is basically a steady non-uniform flow. So non-uniform depth is given as zero point 0.3 meter. We can calculate the uniform depth, which is called y naught. This depth of flow with a flow of for a flow of 1.5 is known as y naught. Assuming n is equal to the value of Manning's n is equal to or Manning's roughness coefficient is 0.016, determine the type of GVF profile. Mean we have to determine the main type and the subtype of the profile from this given data. To determine the profile, we need three values. First one is the Y naught, uniform depth of flow. Second one is the YC, critical flow depth. And third one is Y, which is given in our case, that is zero point 0.3 meters. We have no knowledge or we have no data about Y naught and YC. So in this question, we will determine the values of Y naught and YC as a first and second step. Then we will be able to determine the type of profile for this given data. So simply, what will we do? As Manning's n is given, we will simply apply the Manning's equation for the discharge. As we know that from the equation of continuity, that Q is equal to area into velocity. And velocity from Manning's equation is equal to 1 by n r raised to power 2 by 3 and s naught raised to power 1 by 2. For this equation, we are given with the value of n. The value of n is 0.016. What is R? R is the hydraulic radius. This hydraulic radius means area of the flow divided by the wetted perimeter. Wetted perimeter is basically the distance of the channel along which the water is connected to the channel, or length of the channel. Let us say this one, the water is connected with this side, Y naught, then with the B, and then with the Y naught. So the wetted perimeter is B plus Y naught and Y naught. This will be 2Y naught. And what is area of the channel? That is B into Y naught, width of the channel into depth of flow. That is B into Y naught. If we put the value of B, that is 4, it will be 4Y naught divided by 4 plus 2y naught. If we simplify this, this will be equal to 2y naught divided by 2 plus y naught. We will simply take 2 common. We will take 2 as a common from denominator and we will deduct or cancel this 2 is 4. Here we will have only 2y naught. So this is the value of hydraulic radius to be put in this place. So we will put it as 2y naught over 2 plus y naught raised to power 2 by 3 into what is the value of s, that is 0.0008 raised to power 1 by 2, or you can write it as square root. So we will pick this value of v and will put here in this place. So q will be equal to, what is value of a, area, that is 4y naught. Area is equal to by naught, or you can say here b is 4, it will be 4y naught into 1 by 0.016 to 2y naught over 2 plus y naught raised to power 2 by 3 into 0.0008 raised to power 1 by 2. And now we have the value of q as given as 1.5, so we will keep it equal to 1.5. And then we will start solving by shifting the constant values on the left hand side. It will be arranged like this one: 1.5 divided by 4. This 4 will be divided on the left side, multiplied with the 0.016 and divided by this. 2 is a constant value and has a power of 2 by 3. We will take it out from this value because 2 is a constant. So 2 raised to power 2 by 3 will be taken on this side, and again this 0.0008 raised to power 1 by 2 is multiplied on the right side, so it will be divided on the left hand side. So we'll write its square root, and this term will be equal to, why not? Because we have taken out 2 raised to power 2 by 3 to the left side, 2 plus y naught whole raised to power 2 by 3 into this y naught will be with this one. So we will solve the left hand side. All the constant values will be multiplied or divided, and the final answer will be deduced as, I will just do it for simplified solution. Sorry for delay. It is 1.5 by 4 multiplied by 0.016 divided by 2 raised to power 2 by 3 and divided by square root of 0.0008. It is 0.134. This constant value is 0.134. So we can simply write this y has a power of 1 and this y naught has a power of 2 by 3. So what will this become? Y naught 1 plus 2 by 3 divided by y naught plus 2 raised to power 2 by 3 equal to 0.136, 134. Now we will use the hit and trial method to determine the value of y naught. By hit and trial method using calculator or by taking different values, you can use the hit and trial method. This will be equal to 1 plus 2 by 3 is 1 plus 2 by 3 will be equal to 5 by 2. So we can simply write this term as y naught raised to power 5 by 2. You can increase another step, y naught raised to power 5 by 2, y naught plus 2 raised to power 2 by 3 equals 0.134. By hit and trial method, you will put different values of y naught and on the left hand side at this place and at this place, and you will find the answer of this side. And at last, we can decide that when we put the value of y naught equal to 0.43, the answer of left hand side and right hand side becomes equal to each other. So y naught, if taken equal to 0.43, then the answer of left hand side will be equal to 1.39 something, 1.339 something. So it is equal to, approximately equal to 1.0.134. So the value of y naught is that one which gives us the same values on the right and left hand side of the equation, because right hand side of the equation is constant value. So in left hand side we will put the any value of any random value of y naught, and we'll check the difference between the two, and then we will adjust the value of y naught. We will take 5 to 6 trials by using the but just changing the values in the calculator. Then we will reach to a simple conclusion that our value of y naught is this one, at which the value of left hand side becomes equal to right hand side. So in this case, value of y naught is equal to 0.43 meter. So our problem was about determining the values of y naught and yc, because we are given with the value of y. So y naught is determined as 0.43 meters. Now what is remaining? So our first step, or step A, is to determine y naught. Now is the turn for the second step. So what is the B step? B step is to determine the value of yc. For a rectangular channel, we know that the value of yc is taken as q square by g and raised to power 1 by 3. Q is the discharge intensity. You can also call it as q square by g b square raised to power 1 by 3, because q is equal to discharge per unit width. So we are provided with the value of q, which is 1.5 square, divided by g is 9.81. You can take it as 10 for practice. And b is 4 its square raised to power 1 by 3, and solve it for the value of yc. We will get the value of yc equal to 0.24 meters. The second problem is also solved, because we have got the value of yc equal to 0.24 meters. And now, as we have values of all the depths, which is y naught equal to 0.43 meters, yc equal to 0.24 meters, and y equal to 0.3 meters. At the first step, the step number is 1 to decide the type of profile is to compare values of y naught and yc. This is the first step to decide the main type of or major type of the profile, because in our question we have both the values of y naught and yc, and they are different. It means that the profiles will be, most probably the profile will be from mild or steep slope, because in mild and steep slope we have three values of depths. In all other three, in critical section, in horizontal slope, in adverse slope, we only have one line or one single depth. But in case of mild and steep slope, we have three depths. So from this original perception or initial values of depths, because there are three values and all of them are different, so our initial perception says that the slope may be mild type or slope may be steep type. So now we will see the relation between y naught and yc, and we will judge that either the slope is mild or it is steep. So if y naught is greater than yc, the slope is known as the mild, and if y naught is less than yc, the slope is known to be steep. For this condition, flow is known as subcritical, and for this condition, flow is known as supercritical. And now we will see that what is the relation of y and yc, y naught and yc. Y naught is 0.43, just write 0.43. Is it greater than 0.24 or not? Yes, 0.43 is greater than 0.24. It means that y naught is greater than yc. So which condition is being followed? This one. Why not? Uniform flow depth is greater than the critical flow depth. It means that our type of profile is mild, or we can say that M type profile. When the major type or the main type of the profile is decided, then we will move towards the second step. The second step says to compare value of y. This y is the non-uniform flow depth. So don't compare it, just place it where it comes. Because y naught is greater than yc, it means that yc will be on the right hand side of the y naught. So where will so in this case, another easy method is there. We will just arrange the values in descending order. First of all, you need to write the maximum value, then write the middle value, which is value of y is equal to zero point 0.3 as given in our question. Then write the lowest value 0.24. 0.43 is greater than 0.3, 0.3 is greater than 0.24. What is the symbol for 0.43? This is y naught. This is greater than y, 0.3 is equal to y, and this is yc. If y comes in between y naught and yc, then the profile type is second one. Mean we will have second type of profile, but as the main type is M, so it is known as the M2 profile. If this y comes at the end, means its value is lesser than both of y naught and yc, it will be number third. And if this y comes at the first spot, it will be M1 type of profile, yeah, or first profile. So we can say that the type of profile from this given data is M1 type of profile. Thank you very much. See you in the next video with a new topic. Take care. Allah Hafiz.